Hey everyone, welcome back to Cruise class. Now in today's video we'll be looking at differentiation using the different rules. In the video before we looked at differentiation from first principles and basically the long method of differentiation. Now differentiation by rules would be a series of different rules that we use to differentiate functions, and it usually works for these specific scenarios. Now, first thing that we need to understand is the notations that we may use. Now, a regular function may be expressed as y or f of x. Generically, it can be expressed as f of x, right? So any of these two is usually representing some form of function. And when you differentiate the function, this is how the differential usually looks. So if you differentiate y with respect to the variable x, you will have dy over dx. And if you differentiate the function f of x, you should have f prime of x. Now, I'm just showing you these things so you do not get confused when you see these notations. When you see differentials, they will be represented by something looking like these over here on the right. Now, what does dy dx mean? Now, when differentiating any function, we always differentiate with respect to a variable, a specific variable. Generically speaking, generally most of the times, that variable is x. So dy dx literally means the differential or the derivative of y with respect to the variable x. So dy dx is simply the differential of y with respect to x. Differential and derivative mean the same thing. And remember, the differential of a function is the gradient of that function at a specific point. Now, moving on, the first rule that we will look at is what we call the constant rule. Now, the constant rule, as we can see here, the differential of a constant k with respect to x must be 0, meaning the differential of any constant must be 0. In this example, we see if y is equal to 5, 5 is a constant. The differential of y with respect to x, meaning the differential of 5 with respect to x will be 0. The reason this is a constant is because there is no variable of interest beside it. Remember what we said, the variable of interest in this case is x. And because there's no x beside the term, this term is a constant. So therefore, the differential of a constant is 0. That is a rule that always follows. Now moving over here, we see the power rule. Now for the power rule, this is the most commonly used rule that you guys need to know. The power rule, the differential of any variable raised to a power with respect to that variable. Once more, the differential of this function with respect to x, x is raised to a power. It will be the power, which is n, multiplied by everything raised to n minus 1. So it will be n multiplied by x raised to n minus 1. Now in this example, we will see if y is equal to 3x raised to the 4, the differential of y with respect to x will be 4 times 3 times x raised to 4 minus 1. So we multiply the power by everything. And when we multiply the power, we get 4 times 3, which will give us 12, multiplied by x raised to 4 minus 1. So therefore, the differential of y with respect to x will be 12x cubed. And these are the first two rules of differentiation that we need to understand. And we will move on to another video.